This question says, liquid hexane will react with gaseous oxygen to produce gaseous carbon dioxide and gaseous water. Suppose 3.45 grams of hexane is mixed with 8.9 grams of oxygen. Calculate the maximum mass of carbon dioxide that could be produced by the chemical reaction. And this says round your answer to two significant figures. So this is a stoichiometry problem where we need to find limiting reagent and theoretical yield. And as I've said in previous videos, stoichiometry problems always start with balanced chemical equations. So before we can do anything else, we need to make a balanced chemical equation. So, as you may have seen me do in the past, I'm going to take this formula and make it into basically a molecular formula. So I'm going to count the carbons. 1 plus 4 is 5, 6. So this is C6, 3 plus 4 times 2, which is 8, 11, plus 3 is 14, H14, because it'll be a little bit easier to deal with it in this form. And it says that this is a liquid, so we'll put in there liquid, plus oxygen, which is O2. Notice I'm leaving space for balancing, which is a gas. And this is a combustion reaction, but it tells us we'll get carbon dioxide, CO2, gas, plus water, gas. So this is a traditional combustion reaction. So in combustion reactions, we want to balance carbon, then hydrogen, then oxygen. So my first best guess, because all of the carbon goes into carbon dioxide, is that I will need 6 carbon dioxides. All of the hydrogen goes into water, so I will need 7 waters. This gives me 6 times 2, which is 12, plus 7, 19 oxygens. However, I have as my reactant O2. So O2, because it's even, won't go into 19, which is odd. So I have to double everything. So I put a 2 here, I put a 12 here, I put a 14 here, and then I will need 19 O2. So you double oxygen by just using this number because the 2 doubles it. So that is basically the balanced chemical equation for this reaction. Remember, the balancing is guess and check, so that's what I did. Now, what I want to do is get my plan of attack to figure out how much carbon dioxide I can make from all of my hexane, how much carbon dioxide I can make from all of my oxygen, and whichever one is less is how much I will make, because that reagent will be gone. And when that reactant is gone, I can't make any more carbon dioxide. So let's go ahead and do that. Let's start with hexane. So here we want to go from grams of C6H14 to moles of C6H14. Then once we have moles of hexane, we want to go to moles of carbon dioxide. And the reason we choose carbon dioxide is because the problem asks us how much carbon dioxide we can make. And then finally to grams of carbon dioxide. So grams to moles to moles to grams. You probably are starting to get familiar with this. So starting with 3.45 grams of C6H14 hexane, I want to convert it to moles. So I need to find the molar mass and put it on the bottom. So grams will cancel out. So we do that by taking 6 times 12.01 plus 14 times 1.01, which are the molar masses from the periodic table, which adds up in this case to 86.20 grams of hexane. And on top, 1 mole of hexane, C6H14, times. Now I need to go from moles of hexane to moles of carbon dioxide. To do that, I need to use the balanced chemical equation. So here I see there are 2 moles of hexane. I want moles of hexane to cancel out, so I put 2 moles of C6H14 on the bottom. Notice how I'm labeling everything so I can know what's going to cancel out. And then on top, 12 moles of CO2, because I'm trying to figure out how much CO2 I can make. So I label everything. Times, now you've done this many times. I want to go from moles to grams. I need to use the molar mass. I put 1 mole of CO2 on the bottom. Notice it doesn't matter that this is a 12 here. I use 1 mole because the quality is 1 mole of CO2 is 44.01 grams of CO2. When you do all that math, it's a little bit hard to see, so I'm just going to rewrite that. That is a 2 there. When you do all that math, you get 10.6 grams of CO2. So this is how much carbon dioxide I can make if I react all 3.45 grams of hexane. Now I need to repeat the exact same process for oxygen. This time, grams of oxygen to moles of oxygen to moles of CO2 to grams of CO2. So grams of my starting material to moles of my starting material to moles of my product to grams of my product. So grams to moles to grams. This is a common thing that happens a lot of times. Not every time, but it does happen quite often. So in this case, I'm starting with, you can see here, 8.9 grams of oxygen. So 8.9 grams of O2 times, I want to put 1 mole of O2 on top, and on the bottom the molar mass, which in this case is 32.00 grams of O2 times, now I want to convert from moles of O2 to moles of CO2. I need to use the balanced chemical equation. Since I want O2 to cancel out, I put 19 moles of O2 on the bottom and 12 moles of CO2 on the top. So we use the stoichiometric coefficients when we convert from moles to moles, and only when we convert from moles to moles. And then times, the nice thing is the last step is the same. In both cases, I'm going from moles of CO2 to grams of CO2. So if I'm doing the same conversion, I can use the same conversion factor. So in this case, 1 mole of CO2 on the bottom and 44.01 grams of CO2 on the top. So these are the same conversions. And when I do all that math, I get 7.7 grams of CO2. So one quick word about Sig Figs. This was 3 significant figures, so I put my mass as 3 significant figures. Here it's 2, so I put my mass as 2. I have still not answered the question, how much CO2 will I make? Well, if I react all of my hexane, I'll make 10.6 grams of CO2. If I react all of my oxygen, I'll make 7.7 grams of CO2. That means I will make 7.7 grams of CO2. Because after I make 7.7 grams of CO2, I have no oxygen left. If I have no oxygen left, I can't do this reaction anymore because this reaction is gone. So therefore the reaction stops after I make 7.7 grams of CO2. One quick word about terminology. This is called the theoretical yield. And this, oxygen, is the limiting reagent. Sometimes called the limiting reactant, the limiting reagent or limiting reactant. So the theoretical yield is 7.7 grams of CO2, and the limiting reagent is oxygen. So the limiting reagent is a chemical, and the theoretical yield is usually a grams of some compound.